Good morning, you are joining me. I am Mr. Ish. We're looking here at this double of the day video on quadratics, where we will examine two quadratic style questions, the type that you might see on the variety of standardized examinations out there. Purpose of these videos is always to introduce two questions to help ease anxiety and to help improve instruction with regards to these math questions that are presented. In this question right here, we have to analyze each parabola in terms of its possible solutions. I've seen these type of questions before pop up in a variety of examinations in multiple choice format. We know these are examples of parabolas. You could, in an introductory manner, look at this in terms of the discriminant, which is a portion of the quadratic formula. You know the b squared minus 4ac comes in a radical or a root of the quadratic formula. If this component right here is equal to 0, you know you will have one real solution. If, however, this b squared minus 4ac component in the radical is larger than 0, then you know you have two real solutions. However, if b squared minus 4ac component ends up being less than 0, meaning you're bringing a minus into this radical, you know you cannot do an even root of a negative number, then you can have two solutions, but they'll be imaginary solutions. See, here we have real solution, here we have one real solution, two real solutions, here we'll have two imaginary solutions. How you handle this question right here, analyzing each in terms of its possible solutions, you just have to look at the x-intercepts. Wherever your curve will intersect the x-axis is how many solutions you have. Here you have a vertex at the x-axis. The parabola b is only touching the x-axis at only one point, so b will have only one solution. A parabola is a downward facing parabola. It intersects the x-axis at 2 points. So this will have two real solutions. C is a downward facing parabola in the third quadrant. It'll never reach the x-axis. Therefore, it must have only two but imaginary solutions. And therefore, you'll have no real solutions coming out of C. And your question is done. The key over here is to see at what places your parabola hits or touches the x-axis. Not the y-axis, but the x-axis. And that will lead you to your answer. The second question for this video is more of a manipulation and analysis of a quadratic expression. You have this question presented: if 3x parentheses 2 minus parentheses 3 minus 5x, and you're closing that parentheses, is equal to ax squared plus bx plus c. You know this right here is a quadratic equation with a, b, and c coefficients. If all of this is equal to all of that for all values of x, then you gotta find a plus 2b plus 3c. This whole statement, all values of x, just means that x is an element of all real numbers. Anything from minus infinity to positive infinity, any of those x values can be plugged into places of x and you'll always have a good answer. You could never have an equation where you'll end up with a 0 in the denominator. You could never have a situation where you have a negative in terms of a even radical. So those type of undefined situations do not exist. So how do you go about finding this a plus 2b plus 3c? You gotta convert this form into this form and then proceed from there. And the best thing you can do is use simple algebra and open this up. You have 3x and then you have 2 minus 3 plus 5x. Open this up. You'll have 6x minus 9x plus 15x squared. Write this from high order exponents to low order exponents. Minus 3x plus 0 is your expression. You have your a component here, ax squared. Here you have your b component, and here you have your c component. A is equal to 15, b is equal to minus 3, and c is equal to 0. Plug them right here. A will be 15 plus 2 times b, which is a minus 3, plus 3 times 0. Solve it out. You'll have 15 minus 6, and your answer will be 9. So when it says find a plus 2b plus 3c, this should lead you to your answer of 9, and you would plug that in, or you'd find that among your multiple choice solutions and you'd go for it and it would be right. And that's it for this video. The two questions are presented, meaningful, challenging questions. Thank you for watching. Stay tuned. Have a nice day.